Well, good evening, class. Thanks for tuning in. And so today what we're going to do is we are going to talk about Lesson 6.3. And Lesson 6.3 is going to give us a chance to use the proportions that we learned in the previous lesson. And we're going to specifically use them on similar figures and scale drawings. So let's get started. Okay, so let's suppose that we have two parallelograms. Okay, let's say we have a little one, parallelogram ABCD. Okay, and we have a big parallelogram which is EFHG. I don't know why I didn't go in the same order, but you go around in order. And the symbol for those, and we notice this thing right here. It's like the little wavy equals that we have when we have approximately equals to. And what that means is that the two parallelograms are the same shape, but not necessarily the same size. Now, when the two things are the same shape, we do know some things about their sides. We know that they're going to be proportional. All right, so there's that word, proportion again. So we're going to use proportions to solve them. So suppose in these two parallelograms, suppose I knew a couple of the sides. All right, suppose I know that in the little parallelogram, the left side, the slanty side, AD is x, and that the top long side is 16. And then in the big parallelogram, suppose that I know that the corresponding side on the left, instead of x, is now 18, and the corresponding big long side on the top is 24. Okay, so what we're going to do is we're going to use these numbers and we're going to set up a proportion. Okay, and when I do that, I'm going to go ahead and set up 16 over x. Okay, notice I'm using both sides of the little parallelogram. I'm doing the top side over the left side. So I have to do the same thing for the big parallelogram, top side over left side. So I get 24 over 18. So go ahead and cross multiply that, and you can see that when you cross multiply, you get a cross product of 24x equals 16 times 18. Notice I didn't actually multiply yet because now we're going to divide both sides by 24. Cancel the 24s over on the left. Look on the right, see what cancels, and you can see that the 16 and 24 are both divisible by 8. That leaves us with 2 and 3. And now the 18 and 3 are also both divisible by 3, so go ahead and cancel those. You get 6 and 1. And now you just get your answer, which is 12. Now, we don't ever want to leave a geometric problem with a naked number like that. We always want to label it. So since I don't know whether I'm dealing with inches or feet or yards here, we're just going to put in a random label, which is going to be units. Okay? Now, let's make sure that makes sense. If I put 12 in for x, I can take a look at these two parallelograms, and we can see that 16 is a little bit bigger than 12, just like 24 was a little bit bigger than 18. Okay? So that kind of makes sense. Now, that's not the only way to set up a proportion for these two parallelograms. Okay, so let's look at another way to do it. Okay, suppose I start with the little parallelogram, or better yet, let's start with the top sides. Okay, so let's this time look at the two top sides. So let's compare 16 to 24. So that's the little top side to the big top side, and that's going to correspond to the little left side, which is x, to the big left side, which is 18. Now, this may look like a completely different proportion, but look what happens when we cross multiply it. Okay? We're going to get the exact same cross product. We get 24x equals 18. Oops. Sorry. We're going to get the same cross product, which is 24x equals 16 times 18. Okay? And just to make it a little more clear, I missed it again. Okay? To make it a little bit more clear here. Well, hopefully you can see that right here, this cross product right here is the same as this cross product right there. Okay, let's continue on. All right, let's look at another problem. All right, so in this one, what we're going to do is we're going to have a map. Okay, and let's say that the key to the map down in the corner, it's usually written into the corner of the map, says 1 inch equals 3 miles. Now, suppose I measure two towns on the map, or 2 points on the map, from A to B, and I find out that they're 8 inches apart. Well, I want to find out how far they are in real life. So let's go ahead and set up a proportion. Let's start with the rate that they give us in the scale, which is 1 inch equals 3 miles. Okay? Now, we're going to set that equal to, well, let's see, the 8 inches, that's on the map. So we're going to put that on the top with the 1 inch. Okay? And we're going to put the unknown in the bottom, the x. And now we're going to cross multiply and divide. And I think you can see pretty quickly 1 times x is going to equal 3 times 8. And in this case, there's nothing to divide, so we might as well just go ahead and multiply. And we will get x equals 24. And that is real life. Okay, that's the missing thing. So that's 24 miles. Okay? Now, let's say we were doing the same problem. Let's go the other direction. Suppose that I know that two things in real life are 8 miles apart, and I want to know how far apart to put them on the map. Okay? So we're going to start with 8 miles this time, and we're going to set up a proportion. And this time, we're going to use the same ratio or rate of 1 inch to 3 miles, except this time, since I know the miles, we're going to put the 8 on the bottom as 8 miles. And we're going to be looking for the top. All right, I think you already know where we're going with this. We have a proportion because it's a fraction equal to fraction, so let's cross multiply and divide. This time we get 3x equals 8 for the cross product. 3 times x equals 1 times 8. Divide both sides by 3, and sure enough, I get 2 2/3 of an inch. Okay, and it's inches because we're finding the distance on the map. And again, that makes sense, right? 8 miles is a little less than triple 3 miles, which was in the scale. And so a little less than triple 3 inches, it would make sense that we would draw the two things on the map to be a little less than 3 inches apart. Okay? So again, notice in both of these cases, whether I was looking at similar geometric figures, or if I'm using a scale on a map, or maybe a scale. Another scale that we see a lot is when we're doing model airplanes or model trains. And they might say a scale is 1 inch equals 1 inch in real life, maybe equals 10 feet if we're making this a scale model of a plane or a ship. Okay, and so we will deal with scales, and in each case we set up a proportion just like we just did. All right, the last kind of problem is really kind of cool. Okay, suppose I'm outside and the sun is real high in the sky, and I'm 5 feet tall, and I stop and I just kind of notice, or I have somebody else help me, and they measure my shadow at a certain time of day, and they find out that my shadow is 4 feet. Let's go ahead and put that label in there. Okay. And then let's say, not too far away from me, at the exact same time of day, there's a big pine tree, okay? And its shadow is 30 feet. Well, without climbing way up to the top of the tree, can we figure out how tall the tree is? Well, since the sun is so far away, basically it makes the same angle with the ground, no matter what two objects it is, as long as they're the same time of day, okay? So in both of these cases, we're going to get big, huge triangles, and they're both going to be similar. Okay, so we're going to be able to set up a proportion. And what we're going to do is we're going to take the height of the person that I know, which is me, and I'm 5 feet tall, and I'm a little taller than that, so let's say it's you, or it's one of my students. Okay, and let's say that student is 5 feet tall and is casting a shadow right now of 4 feet. Well, since those are both in feet, let's go ahead and mark which one is the person and which one is the shadow. Okay? Now, let's set that equal to the same thing for the tree. Now, we don't know the actual height of the tree. That's going to be our variable. But we do know the shadow length of the tree is 30 feet. So let's put that on the bottom. Okay, and we're going to solve this proportion. I'm out of room here, so let's do the work down here on the left. Okay, so let's cross multiply, divide. We get 4x equals 5 times 30. Now, again, notice I didn't multiply the 5 and 30 because we can cancel a little bit here. Let's divide both sides by 4. 4 and 4 clearly cancel out, leaving me with x. Okay, and the 4 and the 30 are both even, so I can cancel those, giving me 15 and 2. And so now I multiply 5 times 15, and I get 75, and I divide that by 2, which is equal to 37.5. Now, that's feet, because that was what we were measuring the well, actually, that's what we measured everything in. And that is the height of the tree. Now, it makes sense, right? Because it's a little bit more than the shadow length, just like the person's height was a little bit longer or a little taller than their shadow height. Okay? And you can use this thing for tall buildings, flagpoles, trees, anything like that. Okay? All right, well, let's wrap this up. So what we've done in this lesson is we've got, in a sense, in 6.2, what we learned is we learned how to solve proportions, how to cross multiply and divide. And in this lesson, we learned how to set up really useful proportions and use them to solve real-life problems. Okay? And that's what we're going to be practicing in class tomorrow. So thank you very much for tuning in. My first video, something happened and it got corrupted, so that's kind of why the video played so fast. But we've been able to keep this video for under 10 minutes, which is about 3 minutes shorter than the first video. So hope you enjoyed, and we will practice this in class. Thanks for tuning in, everybody. See you in class tomorrow.